Hey guys, here is your video for what is a function. This video is to follow up from our Desmos activity from yesterday. So if you recall from yesterday, I gave you lots of relations. I gave you some mapping diagrams, some tables, some graphs, and some coordinate points. And I asked you to go ahead and look at examples of things that were functions and things that were non-functions. And from there, I asked you to make some connections and similarities and differences. And in the end of that, I asked you to come up with your own definition of what a function is. And we noticed some very great things. I went through and looked at all of your responses, and I just compiled some of them in 2 slides. So we had some of you that said a function has to have numbers listed in a specific order and the numbers can't repeat. So I really liked this can't repeat part here. I think a function is when you input something, there will always be an output. So I love that we were talking about input and output. And when you put X and Y will always come out. I also think it's where the X and Y or the input and output have something in common, like they're connected to each other for a reason. For example, if I put January in as an X value, I think the number 31 will come out as an output because they share that connection. I loved the vocabulary use that was in this definition. I love that we're trying to make connections between the inputs and outputs. This was really great. A function is a relationship. It is, because a function is a relation. So I really liked this piece. Between an input and an output, there seems to be a pattern with the X values and the Y values. So again, going back to that input, output, X values, Y values, a set of coordinates or a coordinate plane with the input values never repeating. So coming back up here and back down here to never repeating. I think a function is 2 sets of data that are similar. The right side is the X values or the input, and the left side is the Y values or the output. I really liked this one. My conclusion is that a function is a table, so it can be more than just a table, that has only one arrow coming out of each input. So each number in the X-axis. These can be represented using all 3 kinds of graphs. I really loved the connection about only one arrow coming out of each input. Some of the other ones that I really liked, I think a function means a set of inputs that relate to only one output. This was great, a set of inputs that relate to only one output. There can be the same output twice, but not the same input because it wouldn't make sense. Look at the table of months and days. You can't have the same thing for February twice. For each input, there should only be one output. The output is determined by what happens to the input, what the function, process, operation that it goes through to come out on the other side as the output. So in the next slide, we're going to focus on this one a little bit here. The input and output connect in some way. So again, with our input, output, X values, Y values, and then going back to this definition, which I really, really liked. So I just want to sort of highlight here and here. For each input, there should only be one output, and the output is determined by what happens to the input. So what the function, process, or operation that it goes through. So if I look here, I want you to sort of think of a function almost as if it's like a machine, where I put things in and I get things out. So for example, if I put a 2 into my function machine and I get out a 4, and then I put in a 6 into my function machine and I get out an 8, I can see that what's happening in my function machine is that I'm adding 2 each time. I can also see that if I put in maybe something like January and I get out 31, or if I put in something like October and I get out 31, but then I put January in again and I get out 26, well, that doesn't really make sense, does it? So a function is when every input maps to one and only one output. So every input has a pair, and that's its output. So if I look here, when I'm thinking about what this looks like as a mapping diagram, so every input maps to one output. So does 0 only go to pi? It does. Does 1 only go to pi? It does. Does 2 only go to pi? It does. And 3 also only goes to pi. So this relation is a function. Here, 3 only maps to 9, -3 only maps to 9, 5 only maps to 25, -5 to 25, 1 to 1, and -1 to 1. This is also a function. If I look here, 5 maps to 5.49 and 4.5. I can't input 5 into my function machine and get out something different every time. So this is not a function. So every input maps to one output. So looking here, a way to look at that is if I were to think about these as coordinate points, if I were to come over to, let's say, 1, 1 is paired with this point up here, and it's paired with this point down here. So here, this is not a function because my x value, or my input, has more than one output. If I look here, the same thing happens. However, so this is also not a function. However, if I look here, each of these x values only maps or is paired with one other value. So this is a function. And if I look here, the same thing is happening. Each of these x values are only mapping with one other y value. So these two bottom relations are functions. If I look at this as coordinate points, going back to your definitions, a lot of you were talking about how my x values can't be repeated. So 4 maps to -3. Are there any other 4s in the x values? There are not. Is there anything that repeats in the x values? And in this example, there aren't. So A is definitely a function here. If I look here, 5 maps to 3, and if I come all the way down here, 5 also maps to -5. So this is not a function because 5 can only map to one other piece. If I look here at C, 0 maps to 6, 3 maps to 1, -2 to 5, 6 to 4, -6 to 4, 6 to 1, and 9 to 1. There are no values that are repeating here, so C is also a function. Lastly, if I take a look at these graphs here, I can see that 1 right here maps to this point and to this point. This is not a function. I can see that every sort of value here it only matches up with one x value. So all of these only match up with one x value. So B is a function. And if I look here, let's take 5 as an x value, for example. Here and here, it looks like I have 2 values that are paired with 5. So C is not a function. Lastly, looking at these tables, which relation is a function? Here, 3 maps to 3 and 3 maps to 7, so this is not a function. I don't have any values that repeat here, so 1 only maps to 1, 2 to 2, 3 to 3, 4 to 4, and 4 to 5, and 5 to 5. B is a function. Here, February maps to 28, and it also maps to 29, so C is not a function. And here, this sort of really goes against all of the rules of what a function is. 2 maps to 2, but then it also maps to 4, and to 6, and to 8, and to 10. D is definitely not a function. So what I'd like you to do now is go back into Google Classroom, and there's a problem set there that's waiting for you. I'd love for you to do some of those problems, decide which of the relations are functions and which are non-functions, and make sure you can come up with some sort of reasoning as to why. Good luck, guys.